Some of you may have seen this math problem floating around the internet. ABCDE times A equals EEEEEE. So there are 6 E's. Each of these letters stands for a number from 0 to 9. And we don't know which number stands for which letter. Each letter is a unique number. So A cannot be the same as C. E cannot be the same as D, and there are 6 E's here, so keep that in mind. Even though this is a little tricky because we don't know what the letters are or what numbers they stand for, there are still some basic math concepts that we can use to solve this problem. First, starting with E. We know that E times A, the ones place has to be E. And that makes sense because if you consider this just a straight mathematics multiplication problem, E times A, you might have a double-digit resultant. The tens digit will go on top of D, as we know, but the ones digit will be E. So that is foundational. We'll start with that. Given that is a great starting point, we'll start with going down the possible values. So from 0 to 9, we're just going to go through, and I've listed it out here, which values are possible. So is 0 possible for A? And the answer is no, because ABCDE times A cannot equal 0. That would make all of the E's here 0. How about 1? No, in that case, A would have to be 1. And if A was 1, then we would have ABCDE times A equals ABCDE, which is not the case here. It is 6 E's instead. So A cannot be 1, but A could be 2. E could be 2 if A were 6. Again, as long as the ones place of the product is 2. So if A was 6 and E was 2, then you could get 12. So in that case, the ones place would be 2, and we would be okay. So kind of going through the same exercise for 4, right? And then 5. 5 is interesting because A can be 3, 7, or 9. So if E was 5, it can be multiplied by 3. If A is 3, then it'd be 15, right? And you'd have a 5 in the ones place. If A was 7, it'd be 35. You'd again have a 5 in the ones place. If it was 9, it'd be 45, and you'd again have a 5 in the ones place. 6, 7, no. 8, again, yes, as long as A is 6. So we're seeing a theme here. Either 2, 4, or 8 values for E. A can be 6 in those cases. If E is 5, then A is 3, 7, or 9. Now, it may seem that we want to start with E equaling 5 because we have the biggest chance of hitting a possible A value that works. I just went through it straightforward right from the bottom. Okay, and I want to add a note here. So if we consider this possibility of E being 2 and A being 6, okay? Now, I'm going to show you why that can't be the case. Now, this is advanced, so you don't have to, you could do it, you could try it, and it wouldn't work. But this is a shortcut. So if we consider A times A, and we're assuming A is 6 here, right? So that means A times A is 36. So that means at least in these two numbers, it should be 36 or higher. Well, that doesn't work if we assume that A is 2. E is 2, sorry. So if A times A equals at least 36, then EE here is only 22. And that is not going to work. So basically, E here cannot equal 2. We can take out this possibility here. Given that, we're going to start again, just going straight from the bottom. again, we talked about starting with 5, but we'll start with 4 just to show one possibility here. So basically we have 3 possibilities for E is 4, 5, or 8. Moving along, so we're really using a brute force method here. I'm sure there are more intelligent ways to do this, but this is sure to get you an answer. Assuming E is 4, then A must be 6. So again, what we had talked about, E is 4, A is 6, right? We're going to plug those numbers in. The ones place, again, kind of doing the same thing that we did for E, right? The ones place of D times 6 plus carrying the 2 from A times E has to equal E. So the ones place of that has to equal E, which we're assuming is 4. Possible values of D, we'll go with, I'll just show you 1, right? So if we do 1 times 6 is 6 plus 2, that equals 8. So that doesn't equal 4. If we do 2 times 6, it's 12, plus 2 is 14. So yes, we would have a 4, right, where E is. That would fit, because we're assuming that E is 4. And then we carry the 1. So 2 is a possibility for D. We can't use 4 because that's E. We can't use 6 because that's A. How about 7? So 7 times 6, that's 42, plus 2 is 44. So again, the ones digit is 4. That matches up with E, and we would carry the 4 over to C. So we'll just go with 2 to start with, and then we'll go to 7. Assuming D is 2, that means A is 6, E is 4, again from before. So we're keeping A and E the same, and we're adding in D. Again, running through the same exercise, the ones place of C times 6 plus 1 must equal E, which we're assuming is 4. Now, here's the catch. Any number multiplied by 6 will be even, and adding 1 will make it odd. So we're carrying the 1, remember, from D being 2. So that's not going to work. Okay, so there's no way the ones place is going to be 4, D is not 2. Okay, so that doesn't work. Let's move on to assuming D is 7. A is 6, E is 4. Again, from before, possible values of C. Again, here's the equation now. C times 6, 6 is A, plus 4 must equal E, which we're assuming is 4 again. 0 does work. 0 times 6 is 0, plus 4, that works, it's 4. 5 times 6 plus 4 is 34. So we would have a 4 in the ones place, that works, and we carry the 3. Again, 4, 6, and 7 are not going to work because those values are already taken. Good, so assuming C is 0 now, we have C equals 0 or 5. Assuming C is 0, then working through that same equation, 0, so on, B must be 9. Assuming B is 9, we find out that here we have all of our values. So we know A is 6, E is 4, D is 7, C is 0, B is 9, and we just plug in the equation. What do we find out? A times A plus 5 must equal EE, which is 44. Right? We said E is 4 and A is 6. That doesn't quite work, because 6 times 6 plus 5 equals 41, not 44. So B can't be 9, C can't be 0. All right, now that's not the end of the world, because we said that C could be either 0 or 5. Assuming C is 5. Again, we plug that in. D is 7, A is 6, E is 4. Now, again, that equation is B times 6 plus 3 equals E. We run into the same problem that we ran into before. Any number multiplied by 6 will be even. Adding 3 will make it odd. So there's no way it's going to be 4. The ones place will be 4. Therefore, we kind of cross out this possibility. C is not 5, D is not 7, and we said D is not 2, so E can't be 4. E is not 4. So we've taken out 18 here, we've taken out line 20 here, E is not 4. So let's go to assuming that E is 5. Okay, E is 5. I've just moved those numbers down here to make it easier to read. E is 5. A is 3, 7, or 9. Assuming E is 5 and A is 3, just brute force, starting with the lowest values first and moving up. The equation we have is D times 3 plus 1 must equal E, which we're assuming is 5. D times 3 plus 1, nothing works except for 8. So 8 times 3 is 24 plus 1 is 25. So D must be 8. Assuming E is 5, A is 3, D is 8. Again, the equation we solve for C, C must be 1. Plugging that in, nothing works. So there's no value of B. B times 3 plus 0 equals 5. Now, you could say 5 works for B. That's true. But that's already E's value. It's already taken. So B can't overlap with E. So no values work for B. Therefore, C is not 1, D is not 8, and A is not 3. So we're back to the beginning, but we're making progress. So E is 5, but A is not 3. So we'll try it again with A being 7. Assuming E is 5, A is 7. The equation we have here, D times 7 plus 3 must equal 5. The ones place must equal 5. And 6 works. So nothing else works. 6 times 7 is 42, plus 3 is 45. So we carry the 4, and we have in the ones place a 5. Working through this again, we have C must be 3. There's only one value that works for C. Working through it again, only one value works for B, which is 9. And the values don't overlap, which is nice. Okay, so we have 3, 5, 6, 7, and 9. We plug those into the equation here, and our final equation, A times A plus 6 must equal EE, which is 55. We said A is 7, 49 plus 6 equals 55. So here we have our final answer. Again, A is 7, B is 9, C is 3, D is 6, and E is 5.